This conference will now be recorded.
So we'll be discussing today SortKeys. In the last class, we have discussed the distribution keys. So actually, these both SortKeys and distribution keys will be covered under advanced table design. Okay, so yeah, so we have already seen the distribution keys. So today we'll be discussing the sort keys. So as we've seen, the entire performance depends on the what kind of keys we will be creating. Okay, so yeah, so that's why we should be taking utmost care while creating the distribution keys. Otherwise, what happens? Your joins will run longer. Okay, it's because distribution key should be unique. It's not that you will create whatever key you want or whatever key is unique. If that's not going to help, or if that is not used in the join, that's of no use. In fact, it will have more performance problems. So it's always better to create the columns which are used in the joins as the distribution keys. And if these small tables, yes, all distribution keys is better. Okay, yeah, we have seen them. So how if two tables are distributed based on the same column, that is a joining column, how it will improve performance? Because if two tables have the same joining column as the distribution style, so at the time of loading itself, they will be distributed to the slices based on that column. So since both the tables are distributed based on the same column, so they will have matching records in every slice. So table 1 will have same set of data in that slice, and table 2 also will have same set of data in that slice. And table 1 will also have same set of data in another slice, that is slice 2, and table 2 also will have same set of data in slice 2. Similarly, for slice 3, slice 4, whatever number of slices you have, both tables will have same data because they are distributed on the same column. Okay, so how the data will be distributed based on the column which you create as the distribution key. So when you create a column as a distribution key, Redshift will automatically distribute based on that column. So if two tables has the same column as the distribution key, so same column will be distributed by the Redshift. So same value if coming from table 1 or table 2, it will go to the same slice. So there it will have a matching records. So it will join them. So joins will happen locally in case if two tables have the same joining column. So in that way it helps, and in fact that is the best performance if two tables are joining based on their distribution key. Okay, so yeah, and that is first level and the best. In fact, one should take care of that. And the next level of performance optimization is creating sort keys. Okay, so here only is sort keys also will define at the time of creating a table only. For example, distribution style, even, or distribution style, all, or distribution style, key, okay, dist key, or some department number. So like that we give it, right? So here only will mention sort key, and you will give the key name. For example, you want to sort based on location, then you will write here like this, sort key location. So yeah, okay. Today we'll discuss about the sort key and what is the use of the sort key and why we should be creating. Okay, cool. Yeah, so this is today's concept, sort keys. So sort keys basically to improve the performance of the queries. Okay, sort keys are to improve the performance of the queries. If you have understanding of any of the databases, it's like secondary indexes in those databases. Why I'm saying is, for example, if you know maybe Oracle or Postgres or any other databases, I mean any database, there if you know indexes, or if you know the purpose of indexes, you will easily understand this is the equivalent concept. So okay, so you don't get confused with term sort key, or you don't I mean see this word as strange. All the databases and their purpose is same. Okay, store the data and help give best performance during the retrieval. Okay, so every databases will have something called primary key. Okay, every databases will have something called secondary key, and all these things. So only names will change, that's all. Terms will keep different in every database. If you know what is the term, and that's all you will understand. So that's why at least you should know one database, so that you can do comparative study. Oh, okay, indexes. Index means what? It is for better retrieval of the data. Bas. So similarly here, sort key is also to fast retrieval of the data from the data that is stored in the Redshift. Okay. So generally where the sort key is used is on the filtering columns. Filtering columns means on the where clause columns. Where clause columns. So you see, generally all our queries are not just select star from table name, right? So if you give select star from table name, you will get complete data, means the data of the entire table. If a table has 100 records, if you give a select star from table name, it will fetch all 100 records. If your table has 1 lakh records, if you give select star from table name, it will fetch all 1 lakh records. If your table have 100 million records, if you give select star from table name, it will try to fetch all 100 million records. But we don't want all the data, right? We always query data based on some filter. Okay, for example, select star from employee where salary between so and so, or select star from employee where location equals to Hyderabad, or select star from employee where something you will hide date between so and so, or selection of employee where department number equals to so and so. So you want to always query based on some filter, because that's what our business use case is. It's not that same time we want to see all the data. We want to query with different, or we want to see the data with different angles. Angles means dimensions, or different filters. So you always query with some filter because you want to see that particular data. So if you are querying a big table on these filters, what happens is generally it will lead to performance issues. For example, a table has 100 million records, but you want department number 10 data. Okay, let's say department number 10 has only some 1 lakh records out of 100 million. 100 million means 1000 lakhs. Okay, 100 million means 1000 lakhs. Out of 1000 lakhs, you need only 1 lakh. Okay, department number 10 data. Then if you just give select star from table name, then it will fetch 100 million records. So you don't want that. So you will write query like select star from table name where department number equals to 10. Where department number equals to 10 means it should fetch the only department number 10 data. Okay. So but in the background, for example, let's say it is fetching every record and checking whether it's department number 10 or not. And then if it is 10, it's giving, or it's putting one side. If it's not 10, it's discarding. Let's say it is fetching another record and it's checking whether department number 10 or not. If it's 10, it's keeping in the output result set. It's not discarding like that. If it has to scan all the 100 million records, we don't want, right? Means it's like full table scan. It's checking each and every record, and checking whether it's department number 10 or not. Then it's picking next record and checking it's department number 10 or not. Then next record, like that 100 million records, when it will check and when it will give your department number 10 data. So basically this type of processing is called full table scans. Full table scans means entire record will be scanned. Scan means checked for the filter that you have applied. It will fetch the record and it will check whether this particular record belongs to filter value. What do you give filter value? Department number equals to 10. So it will match against that value. So like that it will do for all 100 million. That is full table scan. So if you don't create sort key, obviously it will go for this full table scans. So it will actually waste some time for us. So you need only 1 lakh records because department number 10 is only 1 lakh records, but it is checking 1000 lakhs records, retrieving each record and checking whether it belongs to 10 or not. That means it is unnecessarily scanning 999,000 lakhs records, which is means all other records it is scanning, which is not necessary. Okay, so generally in the real time, yes, we should be always checking on some filter. Okay, and there will be those frequent filters on that column. So on those columns we will be creating sort key bus. So if we create sort key, okay, then what happens? If you create sort key, what happens? If you create sort key, what happens means I will tell you. It will build zone maps. Okay, I'll tell you what is that zone map and all. I mean, again, we no need to get scared or anything. These are terms only, new terminology. Okay, so yeah, so what zone maps actually it is the term given to show like how the data will be stored when we create a distribution sort keys. I will show you that. Yeah, okay. So this is the zone map. Okay. So you see, he is saying terminology and concept data sorting. So basically, the data sorting, the goal, as I already said, make queries run faster. Okay, so basically, I mean, in other way is to improve the query performance of filter queries. For example, you see, before I refer this goal, I said in order to improve the performance of the queries, okay, which are filtered based on some filter or by some where clause I said. So in the entry, he may ask like, if you want to increase same, you see, if you want to, make sure your queries run faster, like what steps you can take. So yeah, so terminology may be different, but what is the thing that finally happening here? We want to improve the query performance. So I directly said, okay, if you want to improve query performance, okay, we need to check sort keys are present or not. So same thing, make queries run faster by increasing the effectiveness of zone maps and reducing AO. Okay, so how this will be achieved? By using sort keys. Where we are discussing this goal we are discussing in data sorting. So that's why we should say this is the application of the sort keys. So yeah, sort keys are basically to improve the performance. That means what? To making the queries run faster. Okay, cool. Then how it happens? How it happens is it happens through zone maps. That's what we want to discuss now. Basically, internally it will build zone maps. I will show you like how zone maps will work, and with sort keys and without sort keys. Okay. So here you see two examples are given. I said right. So create table. Here is a sort key. We just mentioned like distribution key. We will mention sort key. So if you mention like that, what happens is whatever columns you specified in that bracket. For example, you see sort key dt comma location he mentioned, right? So those means you are giving those two columns as the sort key columns. Okay, so what happens is data will be sorted based on those two columns internally. Internally, data will be sorted. Okay, see here. If you don't mention sort key, it will be like this. So here actually is SFO, then JFK, SFO. So there is no sort order. Okay, so in whatever way, it will just be there. But if you give sort key, it will be sorted like this. You see date. See here date 1st April, then May 14th, then October. Okay, so okay, then the next filter date. For example, if you have two sort columns here, okay, date followed by location. First it will sort based on date, and then it will try to sort based on location. Okay, fine. So now it is like this. Okay, after sorting. Okay, so what happens is after, okay, when you make sort keys and before after making sort keys, see here. Yeah, these are called zone maps. Zone maps means it will just sort the data internally based on the sorting column. Okay, it will have some min value and max value. Okay, so and all the values that fall under the category will be present there. For example, you see in the Excel sheet, if there is no sorting, for example, you have like 100 record or 100, I mean 1 lakh records are there. For example, we have all our names in that Excel sheet. Okay, 1 lakh records. If they are sorted, at least you can just check A, B, C in an order. Okay, for example, my name is okay. My name starts with K. Okay, Krishna. So then you can immediately go to the names that starts with K and search my name. You will find it. If there is no sorting, how can you find it out of 1 lakh records? So there is no order, nothing. So it's very difficult. Similarly, you take some salary column. Okay, if that is not sorted based on salary, means any salary is everywhere. Okay, all the records are just there in that Excel 1 lakh record. Okay, there is no sorting on salary column. Then for example, you have to find employee of 50,000. Where you search, you have to search each and every record to know whether he is a 50,000 salary or not. that's too much. But if there is sorting, for example, in fact, in Excel we do, okay, we'll just sort based on that column and immediately we'll go to that 50,000 where it starts and we will find. That's very easy. Just like that we find it. So the same thing, okay. So when we create table with sort key and we mention some column, it will be sorted internally there like this with some in value, max value. Means for everything, for example, if it's a date, okay, so it will give some, for example, January 1st to January 31st, February 1st to February 31st, March the 1st to March, like that. And if you give, for example, some numeric column, okay, something like salary, then it will put something like 1,000 to 10,000 or 10,001 to 20,000, 20,001 to that, like that. It will keep sort internally. So when we give, okay, select star from table name where salary greater than 10,000, it directly comes to that zone map. Same thing like we in the Excel sheet, we want to find an employee with 50,000 salary. We directly go to the 50,000 bracket, right? If we sort the data. If we don't sort, it's very difficult. So it will directly go to that filter and get the data. Similarly here, he is explaining this example with sort key based on date. So when you create sort key based on date, yeah, so it is without sorting, it will be like this. See here, June data is there, June data is there, okay. June, in every zone map there is June data is there. If you want to go for June, where you will search, you have to go to each and everything, okay. So but if you have a sort key created, the data will be sorted based on some min value and max value in every zone map. Okay, for example, let's say it is creating a 1 week filter as a min and max value. Then June 1st to June 6th in first zone map, then June 7th to June 12th, then 13th to 21st, and 21st 30. Like that, it will have some min value and max value in every. So if you put any filter, it immediately knows where is the zone map is. For example, here, yeah, June 9th, 2017. So obviously we know, okay, it will be here. It will directly go to the zone map and fetch the data. I mean, same thing in the Excel sheet, how we get, if it is sorted, for us it's very easy. We directly go to that filter value. I mean, whatever that bracket, 50,000 or 60,000, we'll check. Assuming if it's a name, if my name is Krishna, so you can directly go to that K, where the K letter starts, and you will find. If it is not sorted, then how can you search like out of 1 lakh 1 lakh records, all the names that starts with K? Very difficult. Same thing. So now how to answer what is sort key? Sort key is table design technique, or sort key is, you can say it's a table design technique to improve the performance of where clause or filter columns. You can say like that, or you can also say sort key is used to improve the performance of where clauses or filter columns. So I mean, if you are very advanced in knowledge, you can say the first definition, it's a design technique and all that stuff. Okay, I mean if you're strongly and if you're very good, and I mean you can tell like that. Otherwise, simple developer answer. Sort key is a technique used for improving the performance of the queries in the Redshift. Internally, it will create zone maps, and each zone map will be created with min value and max value. So since the data is sorted in the zone map, so whenever we query a table based on some filter, it will directly go to that zone map and fetch the data. But simple. You no need to expose as you are some advanced. You no need to even think like that. You just be normal as you are and try to answer whatever you know. Okay, so that is sort key. Sort key is basically, what is the purpose? It is to improve the performance of where clause. That is the main thing. Once you set that, then of course, if you know how it will do, you can tell that also. Okay, so when we create a sort key on your table, data will be sorted internally in the zone maps with some min value and max value. So when you query a table with some particular filter, here what is the filter we applied? We applied date equals to so and so filter. It will directly go to that zone map and fetch the data, and it will get the data. Bus. Thus, it will avoid unnecessary table scanning. Okay, it will avoid unnecessary table scanning. Table scanning means what? It will waste a lot of I/O and make the system busy unnecessarily. Same thing you see in the Excel sheet. If you have 1 lakh records and if it is not sorted, to find 50,000 salary, you are seeking each and every row in the Excel, whether it's 50,000 or not 50,000 or not 50,000. So it's wasting all of your time, right, and your energy. You're checking everything. So here, all is the energy of the system. It's a CPU and I/O. So all the I/O will be wasted. Okay, cool. So that's what here it is said in the goal. So make queries run faster by increasing the effectiveness of zone maps and reducing I/O. So it will reduce the I/O. How it will reduce the I/O? Because it will not check unnecessarily all other zone maps. It will directly go to the respective zone map where the data is there, and it will fetch the data. Bus. Okay. So how it will improve that? See here, how it will do is range restricted scan. Range restricted scan means it will not check all other filters. It will go to the filter where it is stored. What is that filter? Every min value, max value is there, right? Min value, max value is a filter. See here, it is first to sixth, that is one zone map. 7th to 12th, that is one. So this is called range rest. Range means some min value and max value will be there. That is called the range. Range means some starting value and ending value will be there, right? So what is the range of the something like that we'll say min value, max value. So it will have range restricted scan. So when you query based on some filter, for example, here you see data, so it will directly go to there and fetch the data bus. That means it's not scanning all the data which is there in all other zone maps. So thus it will improve the performance. Enables range scans to prune the blocks by leveraging. To prune the blocks means it will not scan other blocks. Okay, so as it directly goes to the respective zone maps. Okay. Then achieved with table property means what it means is you will be specifying it at the time of creating a table. Is achieved with table property. Table property means at the time of creating a table, you will create sort key and column name like that. That's what it means. Achieved with table property. Sort key defined on one or more columns. Yes. Some people will ask whether can we have more than one column as the sort key. Yes, we can. We can create more than one column as the sort key. Okay, so the next question, can you tell me what type of columns we will be creating sort key? Very simple. If you understand till now the concept, then I already said sort key will be created on the columns which are used in the where clauses. Where clauses. So on whatever columns your queries are mostly queried, okay, on whatever columns your queries are mostly queried, on those columns only you will apply this. That's all. So if a particular table is queried based on some date, then on the date you will apply this sort key. If some tables are queried based on some salary, then on that salary only you apply this sort key. So here the theme is on whatever column the table is most frequently queried or filters are applied, on that column you will create. So then somebody may ask, hey, I have more than two columns which are queried most frequently, then yes, you create on those 3 columns. So like that. So that's what. So he may ask, can we create more than one column as the sort key? Yes, you can. Okay, cool. So generally he will ask what is sort key and what are different types of sort keys. Or he will tell like, can you please tell something about sort keys? Okay, so when he said like that, you should tell everything that you know about sort keys. Okay, sort keys are basically to improve the performance of filter where clauses. Where clauses or filter clause filter. Okay, filter is to filter the data, right? So that is applied using where clause. So just say where clauses. Okay, there are two different types of sort keys in Redshift. Okay, two different types. What are those? Compound sort key and interleaved sort key. What are different types of sort keys? Compound sort key and interleaved sort key. When you don't mention anything, see here, I did not mention anything here. I just mentioned sort key. Means it's a compound sort key. If you don't mention anything, it's, for example, here you may think that since 2 columns are there, so no. Even if you have 1 column also, here since I did not mention anything like compound, if you mention, yeah, you will clearly understand it's a compound sort key. But I did not mention anything. Still also, that's why it is called by default. It's a compound sort key. Okay. So compound sort key does not mean that it should have more than one these columns. No, even single column also it is some compound sort key if you don't mention anything, or if you mention, yes, this automatically compound. But for some compound sort key, we generally don't mention anything. We just leave it as it is. Okay, that's a compound sort key. So in compound sort key or even interleaved sort key, you can mention more than one column as the sort keys. Okay. So then the what is the next type of sort key is interleaved sort key. Okay. In interleaved sort key, what happens is, see here, a sort key is given based on country, state, city. Okay. In interleaved sort key, it will give priority to all the columns equal weightage. If you have mentioned 3 columns, then it will try to give weightage, equal weightage to all the columns. Okay, but yeah, here it is interleaved. If you give interleaved sort key like this, okay, so what it does is it will try to give equal weightage for all the columns that you mentioned here. But if you give compound sort key, for example, like this compound sort key, then your weightage, the processing internal mechanism will differ. That's what I'm saying. The how it will be sorted is, or how it will be given, it will be given more weightage. Okay, left hand side. Okay, it will process from left to right. Okay, so left column, then next left, then next left. Okay, order will be more important in compound sort key. In compound sort key, order will be more important. Okay, in interleaved sort key, order is not important. You can give anyway. Okay, it will give equal weightage. Okay, but in compound sort key, you have to mention order important. Okay, then what is that order? What is that order is, see, okay, I will tell you. Left to right. You see, country is left hand side, right? country is left, then next left state, then next left or right side is city. So left to right, increasing cardinality means more unique values towards right, more unique values towards right, and more non-unique values in the left. For example, you see you have some customer table. Okay, in customer, yeah, definitely customer ID, customer name, everything will be there. Then customer city, customer state, customer country. Which values will have more duplicates? City, state, or country in that table? Which values will have more duplicates? City,
City.
state, or country? More duplicates, not unique values.
Country, sir.
Yeah. See, even if there are 100 million records in that country, for example, we are taking only India data, then all 100 million records will be only India only, right? For country column. For states, yes, some values will come like AP, UP, okay, something like that will come. Delhi, MP. So some unique city, you will get more unique values. There are so many cities in India itself. So I'm asking, which will have more duplicates? Which field has more duplicates? Country or state or city?
Country, sir. Country.
So now, so,
Yeah, for compound you are asking, sir. For compound sort.
no, compound or anything. I just said three values are there, let's say in a table. I mean, not only three, customer values are there, and among all the columns, customer ID, customer name. After that, country, state, city is there. So it has 100 million records. So if it is 100 million records table, among these three, if you talk, which field will have more duplicates? City or state or country? More duplicates. Yeah,
Country will have.
because so if you're talking about only India customers, let's say these 100 million, so country will have all 100 million records will have India only, right? So yeah, and state column will have, for example, we have some, I think some 30 plus states. Then out of 100 million records, all of them will be only some 34 values will be there. They are repeating. But in city, I will have more values repeating because every state has so many cities. So our question, which will have more duplicates, means obviously the country will have more duplicates because only India will be repeating in all the 100 million records. So my point here is compound sort key. You should mention the columns in order left to right, more duplicates to less duplicates. Means while going towards right, your unique number of values should increase. So city will have more unique than state. So state will have more unique than country. So it will be like this. Or in other words, less number of unique values should be there at the left hand side. So less number of unique values will be there in country, so that should be on left side. Then next less number of values, that is state, so that should be next left side. Then more unique values towards right. In that way, we should create compound sort key. Compound sort key should be created in such a way that while going towards right, more unique values should be there among those columns. So that's we mention it as more cardinality. Cardinality means unique number of values. So less cardinality to more cardinality, while from left to right. So left side column should be less cardinality, means most unique values, less number of unique values. So in country you will have how many unique values? As per the example I said, India only one value, unique values. But in state, of course, you will have some 30 plus unique values because in India you have some 30 plus states. But while towards city, you will have even much more unique values. So while creating compound sort key, while from left to right, you have to create increasing granularity level, means less unique values, then more unique values, then most unique values, like that. So order is important. So yeah, so that will in fact improve the performance best. But in interleaved sort key, it's not like that. You can give any way you want. Okay, so yeah, but for performance reasons, it's not advised to create interleaved sort key because it will give some performance issues during internal processing. It's always better, okay, even because in Redshift we'll be creating some copy jobs and all. So even Redshift advises us not to create interleaved sort key as it has some internal overhead. Compound sort key will help, for any performance optimizations. Okay, so yeah, it's advised not to create interleaved
So what
sort keys
happens?
unless,
So
yeah,
what happens in interleaved sort key? I didn't understand that. Like,
yeah. What happens is, see, for example, it has equal weightage, right? So I will tell you one example.
yes, sir.
So
Example will be.
yeah, select star from customer where city equals to Bangalore. Okay, let's say you gave it like this. Okay, and state equals to Karnataka and the country equals to India. So for example, if you give this query, okay, for example, this customer table has sort key, okay, in this order, compound sort key. Okay, so it will process starting with the city filter. Okay, so city equals to Bangalore. Finish, it will immediately get the data. You no need to apply even KF filter and India filter. City Bangalore means obviously automatically state and country is taken care, right?
Yes.
Taken care or not?
Yes, sir.
Yeah. So and that too, we have seen it is first sorted based on city because it's there in the right side. Okay, for example, you see, we have seen here. Okay, just second. We also will see there is a documentation on this. I will refer as we are discussing on this. Okay, so anyway, first we'll cover this and then we'll go to documentation. So
So,
best
so one
practice.
thing.
I will.
So, yeah. So one thing, just one question, like how the zone maps will are related to the slices or the nodes, like a particular
Actually,
slice will have zone or how many zone maps are there?
no, zone maps are created on the not in slices or anything. Okay, because slices are internally linked to the disks only, right? Slices are internally linked to disks or no?
Yes, yes.
Yeah.
So data is
So
not stored in a sorted manner here.
yeah, not in slices. Okay, slices are, those are all the processing units. They will only process. Means if you apply any filter, it will filter. If you apply any aggregates, it will try to calculate aggregated values like sum, min, max. But actually, where are they getting data? Or while loading, where are they putting data? They put data on disks only. But in the disks, how they are sorted? In a block wise, right? 1 MB block, we said. Okay, so otherwise you see the terabytes of data that we are loading into warehouse, it's not that slices will hold all the data.
Yes, so
Yes
in
or
case
no?
of distribution key, you mentioned that based on the keys, it will be stored in slices, right? Means in the disk ultimately.
Yeah, when I say slice, generally I will say slice and all, but we should know that it in turn go to disk. Otherwise, for everything I should say disk and disk and disk, right? It's not like that. It should, yes, it should be ultimately where is your data is residing? Disk.
So in based on the distribution key, data is residing in the disk. But here also based on the short keys, data is residing in the disk, or and this is something not related to disk.
Yeah, yeah. But every data is retrieved through slices only. How it went? In that way, it will. Yeah. Can you hear me?
Yes, sir, I can hear you now.
Yes, sir. Yes, sir.
Okay. Yeah. So yeah. So basically, yeah. Even the zone maps are connected to the slices. Yeah, that is the point. Okay, zone maps, they're all will be built on the disk only, because on the disk blocks will be there, right? Blocks means your data. Okay, so they will be accessed to the user through slices only.
So,
Okay.
sir, how it is decided, like which zone maps will go to a particular slice or which node it will go? How is it decided?
You see, every slice will have, because every slice will store the data or not.
Yes, yes. Like in case of distribution, we mentioned the style, all even, so that it knows where to go and how to store. But here, in case of sort zone maps, like
Yeah,
how it will.
wait. Yeah, because it is sorting whatever data that is already distributed to the slice. You
Okay,
understand?
it will before it will not sort and put. It will sort after it is being put. It will sort them. That is what.
Obviously, right. If without data, what it will sort?
Okay, in
If
that
is
scenario, sir, then it has to go through many scans, right? Because while storing the data, we are not sorting and storing. So in that case, it has to again go through different many scans.
wait. It should be first distributed to the slices, and then only sorting will be applied.
Hmm.
You see, actually, sorting, there is no compulsory that sorting should be there at the time of creating a table. You can create sorting anytime. Okay, so even sorting is there. Okay, first, what is primary thing when you create distribution key? Data should be distributed, right? Yes. Once data is distributed, then if there is a sorting on the table, sort key, then it will be put on the respective zone maps based on the min and max value. And these zone maps will be present in every slice. Slice means, yeah, underlying disk, because in every slice data is there, right? Hello.
Yes, yes.
Yeah. So you understand? You see, distribution key will be there. Distribution key will distribute. But if sorting is there on the table, it will sort. Otherwise, it don't sort. Bus. So in order to sort, first this is actually distribution and sorting, they are two different. Okay, distribution key you can drop anytime. Anytime you can add a sort key. Okay, so if you add a sort key, yes, it will be sorted based on the zone maps, min value, max value. If you don't, then it will be just created is like this, unsorted. It will be, and yeah, zone maps will be created in every slice means, yeah, the underlying where it is stored, because every slice need to fetch the data it is storing, right? Every slice need to fetch the data it is storing, or the data which we stored in slice 1 will be retrieved by slice 3? No, right? Slice 1 data cannot be retrieved by slice 3, right? Slice 1 data means the data which is distributed to slice 1 can be retrieved by slice 1 only. Yes or no? That point you answer, Somnath? Slice, for example, the data distributed to slice 1 can be retrieved from slice 1 only. Yes or no?
Yes.
Yeah. So in case of sorted table, it will come from the slice 1 zone map. That's all. Similarly, every slice is connected to its respective zone maps. So it will come to the respective zone map.
Okay.
Are you clear?
Yeah. Yes.
Yeah. So the same set of zone maps will be created under each slice 1, because each slice has their own data. Out 100 million records are distributed to all the slices, right? So in each slice, it will try to get the, for example, for example, this is the filter. In each slice, it will try to go to this zone map. Like that, every slice, it will try to go their own zone map between 7 to 12, and it will try to get the data. So in that way, it improves the performance at the slice level. Then finally, whatever data gets from all the slices, yes, that's out of all 100 million records, because the data is distributed to all the slices. So the zone maps also will be built respect to the slices, and it will go to the respective zone map. Okay.
Yes, sir.
Okay. Cool. But anyway, this
So
is an internal
sir,
thing. Yeah.
so zone map process is in slice level, sir.
Yeah.
And
Everything
ఈ process on
happens. Everything happens behind the slices. Even storing, everything. Okay. So, but it will go through slice. Processing only happens in the slice. Even slice means it will have memory and all, right, main memory. So processing. So yeah, while distributing, it will go through slice to background disks. And before disk, yeah, zone maps and all will be there on the disks only. Like that, every slice will have their own zone maps and their own blocks. Blocks means disks on the disk. So yeah. Okay, here the point you need to remember: when we create sort keys, zone maps will be created. Okay, and zone maps will be created with min value, max value. So whenever we query a table with some filter, it will directly go to that zone map and get the data. Thus it is avoiding full table scans or not? That point you answer. It is avoiding full table scans or not?
Yes.
Prasad, it's avoiding in full table scan or not?
yes, sir.
See, full table scan means checking each and every record or checking each and every zone map. It's not going to check each and every zone map, right?
Yes.
Yeah.
Sir, in zone map, min value, max value, it will the 1 week period. How it will decide that 1 week or
It's not 1 week, boss. It is the example. Okay. It can create 1 month or it can create, okay, based on how much data it has. not
Okay.
one. It's just example.
Okay. Based on data.
Okay. Yeah, based on the data.
Okay.
Okay, it's not 1 week or anything. For
Okay.
example, if it is a date, so it is 1 week. What if it is salary? So we should use our common sense. Based on the column, it will take, and also based on the data. If it is salary, then it cannot follow date format, right? It will try to use something like 0 to 10,000 or 10,000 to 50,000, 50,000 to 1 lakh, like that. Or for example, if it is a city, then how the zone maps will be created? So it will exercise, okay, internal algorithm. If it is city, yeah, it will try to create zone maps based on city value. Yes or no? Some city name.
Yes, sir. Yes, sir.
Yeah, like that. So when you apply filter based on some city equals to Hyderabad, it will directly go to the zone map which is storing that Hyderabad, and it will get. Or yeah, within that Hyderabad, there may be some pin codes. So it may apply this zone map based on pin, because city will have many pins, right? Pin code. So it may apply based on like that. So based on the data, it will store with min value and max value. And of course, it's all internal mechanism. We no need to worry. It will understand where it stored the data, and it will get the data. We just need to know how to create sort key and how the sort key will function. Okay.
Yes, sir.
Yeah.
Yes.
So yeah. So okay. Now yeah, I will just show one thing. Anything, if you need to study about, just come to Google and type that particular concept here. Okay, Redshift sort keys. Then refer the links docs.aws.amazon.com. Only these links. You don't need to go to anywhere else. Okay, and you open the respective links and see. There he will tell you about, like what is sort key and all this stuff. Okay, see, and what are different types of sort keys: compound sort key, interleaved sort key. And he will be talking about what is this compound sort key and what is this interleaved sort key. He will tell. See here, the same point I mentioned here. Don't use interleaved sort key on columns with monotonically increasing attributes. Just identity column, dates, or timestamp. Okay. You see, and here the point is, the performance improvements you gain by implementing an interleaved sort key should be weighted against increased load and vacuum types. So basically, it will impact the vacuums. Okay, and if it has more data, it will impact the performance. Okay, so that's why he said don't try to create interleaved sort key. Anyway, if we read it, we will know. But first, let us read about compound sort key. I mean, same thing, whatever I said. A compound sort key is made up of all of the columns listed in the sort key definition. Means I said, right, one column, two column, we can mention any column. That those are all created compound sort key. Yeah, I see. In the order they are listed, so that order is important here. Okay, so order I already said, from left to right. Low cardinality to high cardinality means low number of unique values to high number of unique values. This a compound sort key is most useful when a various filter applies conditions. Yeah, basically the sort key should be created on filtering columns only. Okay, if you create sort key on a column which is not used in filters, then it's of no use. Okay, a compound sort key is most useful when a query filter applies conditions such as filters and joins that use the prefix of sort keys. The performance benefits of compounding sort key decreases. You see here. The performance benefits of compound sort key sorting decreases when queries depend only on secondary sort columns without referencing the primary columns. Means he is mentioning your sort key. I mean the same thing, the order we mentioned, right? The order. If we apply based on state, okay, if the state column is not referencing country, then it will not be much useful. That's what he's saying. That's why you see, always this should be superset. Obviously, right? Country is a superset, then state. Then state is superset of city. So like that. So whatever column is there in the right side, okay, it should be part of the left hand side. That's why, I mean, instead of saying all those things, we'll say that, yeah, the left to right, low cardinality to high cardinality. Okay, that is the mathematical or technical terms we can say, or database terminology. Then it will automatically take care of the conditions that is specified. Okay, so for example, if you put city equals to Bangalore, it automatically covers, or because it's a subset, it automatically covers Karnataka and India. But if you put city equals to only India, it has to fetch all the data. Yeah, if that is the only filter, that's fine. But if you want Karnataka data, then yes, the if you want, for example, Bangalore data, yeah, this sorting should be in this way. If you're applying filters on Bangalore, state, country, and all. Okay, so always left to right, low cardinality to high cardinality, means more duplicated columns to high duplicated columns of the columns that you want to select as a sort key. So the performance benefits of compounding sorting decreases when queries depend only on the secondary sort columns. Means when they are not depending on the primary sort columns. Means left hand side without referencing the primary column. Yeah, they should refer the prime means left hand side column. Compounding is the default sort key. Okay, so it is the default one. Okay, so if that means if you don't mention, just mention sort key, it's a compounding sort key. That's all. Okay, so interleaved sort key we will see. An interleaved sort key gives equal weight to each column. Yeah, in fact, yeah, this is the problem actually. An interleaved sort key gives equal weight to each column or subset of columns in the sort key. If multiple queries use different columns for filters, then you can often improve performance for those queries by using an interleaved sort key. Means if there are different people and they don't know, like, what type of columns they query and all, they don't know. Okay, they have some 100 columns and users are using, whatever column they want to use. At that time you can give this. Okay, but we know that in the business, people are, in fact, for every business we know, okay, generally on what type of columns they will query. Okay, so if multiple queries use different columns for filters, then you can often improve performance for those queries by using interleaved sort key. When a query uses restrictive predicates on secondary sort columns, interleaved sort key significantly improves query performance as compared to comp. Okay, see, when query uses restrictive predicates, yeah.
Sir, equal weight to each column means what happens, sir? I can't understand. Please tell me in some Telugu sentence.
Sorry, equal weight.
ఈక్వల్ వెయిట్ టు ఈచ్ కాలమ్ వాట్ హ్యాపన్స్ సార్ నాకు అది అర్థం కాలేదు సార్ కొంచెం తెలుగులో ఒకసారి చెప్తారు సార్
Yeah,
అంటే వాట్ హ్యాపన్స్
yeah, you see, equal weight means equal priority. For example, you see, wait, you see, interleaved sort key I created on these three columns, right? Interleaved sort key, yeah. Okay, so I applied, I applied filter on country, and somebody applied filter on state, and somebody applied filter on city. Or I wrote a query. Okay, I wrote a query. Yeah, the same query. Okay, where Bangalore equals city equals to Bangalore, state equals to Karnataka, and country equals to India. Then let's say, yeah, in its perspective, all are same. Okay, city filter same, state filter same, country filter same. Let's say it's first fetched the country equals to India. Let's say it first fetched the country equals to India. Then how many records it's fetching? 100 million records it's fetching.
Yes, sir.
Yeah. Then let's say it's applied state filter. Then let's say state filter. Yeah, Karnataka is fetching something like some 50 lakh records or 5
Okay,
million records. Then finally it applied, let's say, Bangalore filter. So Bangalore, I said it's only 1 lakh. 1 lakh. So actually Bangalore records are only 1 lakh. But because of the equal weight is what it did, it is thinking I can query any column. So it is, let's say it thought I can fetch India data first. Then unnecessarily it is pulling 100 million records, right? 100 million. Then 1
yes,
million
sir.
makes 10 lakhs. Okay, 100 million means 1000 lakhs. So let's say that, let's say it thought, okay, I can fetch first state data. Then 5 million. 5 million means 50 lakh records. Then what is the use of filling 50 lakh records, but where actually you need only 1 lakh records? That is what
Yes,
equal weightage. Equal weightage means, you see, for example, in a team of 5 people, let's say you are given asked to select 6 person out of, let's say you are given 3 players, and they gave, okay, you take out of 3 anyone, means you gave them equal weightage, means you can take anyone. That you understood, right?
yes, sir.
Yeah, means they gave you 3 people and asked you to select one, means it's your choice, you can select anyone. Okay, they did not put, first you select this guy, he is first, then you guys, no, not like that. Means the weightage given to you, you can take anyone, means all the 3 of them are rated at the same weightage. Okay, then only they will say
Yes,
you can take anyone from these 3.
yes, sir.
Yeah, that's what weightage means. Weightage means you can take any column and put apply filter on that.
Yes,
Okay,
sir.
you have given 3 columns and it is giving same weightage, means what, let's say we put weightage on country and take filter, then you end up filtering or querying 100 million records, which is no use.
Yes, sir.
Or let's say it gave weightage to state, and then it end up querying 50 lakh records, that is also no use, not right use case. But if you apply filter on city, then only you will get least cost and best performance. But this is automatic in case of compound sort key. In compound sort key, it will automatically fetch based on this city, provided you put in this order. That's why order is important here. It will automatically fetch, okay, with the least. Okay, so highest granularity means it will query from right. Okay, so that will happen only when you put order in this way, means least granularity to highest granularity from left to right. If I give equal weightage, then I can query any column you will think which is not right. Yes or no?
Yes, sir. Got it.
Yeah, that is equal weightage. Okay, you understood,
Yes, sir.
right? Equal weightage, what it
Yes, yes,
means.
yes, yes, sir.
Yeah, so even AWS says don't use interleaved sort key and columns with monotopical increasing attributes. Okay, increasing attributes means if you have more columns, okay, in the sorting, and if you are using interleaved sort key means what? It can take any column during filter, so that's not good. Okay, increasing attributes when you have, I mean, increasing attributes means when you have more columns, if you put as interleaved sort key, then that's not going to help much. because it will internally affect, during the time of vacuum and all. Okay, we will see what is this vacuum and other stuff. Yeah, that's a separate concept. So interleaved sort keys most effective with highly selective queries that filter one or more of the sort keys columns in the where clause. Yeah, he's saying, you see, the benefit of interleaved sorting increases with the number of sorted columns that are restricted. The means, you see, if you have maybe one or two columns, okay, as a sort key, then interleaved sort key, that's okay, because it can only select that one or two. But if you have, some 10 columns, and if you give interleaved sort key, then that's not going to help. Okay, it may be beneficial if you just put, okay, interleaved sort key if there is only one or two columns in the list, because it will select either this or that. Okay, but yeah, it's not advised. Okay, if something can be achieved more accurately using compound sort key, then what is the need to go with interleaved sort key? That is the best practice. What is the best practice? Try to always create compound sort key, okay, from left to right in an increasing granularity level. Means left side low granularity towards right side high granularity. Okay, cool. So I mean, if you can present like this, that's enough. Okay. Why? Because this is not the deciding factor in your interview bus. But you should know what is sort key, okay, what is zone map, what is compound sort key, what is interleaved sort key, what is better, what is not better. That is you're expected to know. Okay, but don't go deep dive into that. This is what you need to know. If you know that, that's fine. You will just go to the next level. I mean, next question, because the next priority questions are not yet started. Even in the interview, I'm saying, or even now. Till now, yes, what is sort key? Sort key, sort key will act, yeah, in Redshift, we create sort keys. For example, if you observe, you see, I'm not telling the by-hearted or mug-up kind of definition. I'm just saying, yeah, sort key means actually what is the use of sort key. That's what you also need to say. Sort key is basically used to improve the performance of filter queries or where clause columns. How it will improve the performance? Because internally it will create zone maps, and the zone maps will automatically create, yeah, whenever we create sort key, internally it will create zone maps, and zone maps will sort the data with some min value and max value. Yeah, the terms you should, zone maps term should be there, and it will store the data with min value and max value. So whenever you query a data with some filter, it will directly go to the zone map and fetch the data. Bus. That's all. Because you don't find zone maps information in the documentation, because that is internal to the AWS. Even the interviewer don't know anything about zone map. In fact, that's not required. AWS don't share that information with anyone, how it internally functions. Okay, so but everyone is shared till to this extent through this, through this material. Okay, everyone knows up to this point only. Okay, internally zone maps will be there. Zone map will sort the data based on with some value, max value, and whenever you filter to this, it will go to the respective zone maps and get the data bus. And more than this is not more than this is not required. But you should know what is compounding sort key and how it works. Compounding sort key, by default it is the compounding sort key. It should be there from low cardinality to high cardinality. Okay, so that it will give the best performance. But interleaved sort key, if you have multiple columns as interleaved sort key, since yeah, it gives the equal weightage. So equal weightage means what? Like I said, okay, you don't know whether it's applying the correct filter or not. Okay, so it basically yeah, end up getting the data which may not be required. So, and that also when multiple users are querying, okay, multiple users are querying the same table, okay, same, for example, one person is applied filter on country, okay, on the same table, customer table, and one person is applying filter on state, then it may not be able to select the right column to apply the filter to get the data. So at that time, okay, so it is not a good choice to have better performance. That's why AWS says don't try to create interleaved sort key. It will impact the other things like, you know, other internal things like vacuum and all. Okay, so interleaved sort key is better. I mean, if you want to create, first thing is better not to create. Or second thing is, if you want to create, then yeah, you can create if there are only one or two columns as part of sort key, then no problem. But if there are more columns in the sort key, then interleaved sort key is not advised. Okay, so compounding sort key is always the best practice. You can just say that AWS advises. Just put on AWS because it is AWS recommendation. AWS advises to create compounding sort key from low granularity to high granularity. Okay, that will help better. Okay, so yeah, by default it's a compounding sort key. Okay, what happens when you create sort key? Internally it creates zone maps. Okay, internally it creates zone maps, and in the zone maps your data will be sorted with some min value and max value. Okay, so whenever you apply a filter, it will directly go to that particular zone map and will fetch the data. In that way, it will reduces the amount of data that need to be scanned, thus improves the performance. Okay.
Yes, sir.
Yes.
Yeah. Prasad, you understand what is full table scan? Do you know actually what is full table scan?
Yes, sir.
Okay. Yeah. Full table scan means checking each and every record.
The entire record.
Okay. Yeah.
Yes, sir.
Not entire record. Every record of a table.
Every record. Yes, sir. Every record in table, the entire copy of table.
But sir, I have a
Yeah.
question here. Redshift itself stores data in a columnar fashion, right? So, so whether full scan happens or not, so ideally should not happen.
Yeah. That's why I was saying full table scan happens on an entire table. I'm not, you see, full table scan on a row level storage happens for entire record. Prasad is saying entire record. Actually, I said not entire table. And here table is stored based on columnar, right? So it will check all the column IDs. So no, it will check all the columns irrespective of the applied filter.
Okay.
Full table scan happens for all the records of a table, not entire record. Record means checking all columns of a record. Okay. Here, for example, where salary 50,000, then it will check salary column is stored on every block, right? So it will try to check all the blocks where this salary is stored. That is full table scan. That happens at the column level. You understand, Somnath?
Yes.
Yeah. Prasad, you understand? You see, full table scan means here, full table scan, it don't check for other columns. It will check on the column where we applied filter, but every value it will check. You don't bother about
Yes,
other
sir.
columns. Okay.
Okay, sir. Yes, sir.
Yeah, because it's a columnar storage. But in row level storage, because the other row columns also there, so it has, in fact, the filter is not applied on that column, so you don't bother there also. But it will fetch the entire record while checking or while comparing. Okay.
Yes, sir, clear
Prasad.
now.
Yeah. Prasad, are you clear? What is
Yes, sir.
full
Yes, sir.
table scan?
Yes, sir.
Okay. Okay. Yeah. So last time we discussed about compression, right? Do you remember what is compression? First of all, did we discuss it or not?
We didn't discuss. We just said that there are compressions that will do, but yeah, we didn't discuss in detail. Are there any types?
There is no types. Okay. Anyway, I will just okay. So shall we do it or shall we do it tomorrow?
I don't have a problem, sir. Your wish.
I don't have
Anyway,
problem.
okay, then fine. So yeah, after sorting, the next concept will be encoding. Yeah. So it's a very, I mean, it is just the term that you need to know. I think I already said, but let's see. Yeah, I already said. Compression is basically, I said, right, in the desktop and all, we minimize the file, right? What is, we compress the files? Why do we compress? To reduce the file size, right? Especially when we are attaching larger files to a mail or something, it will not allow the larger size. At that time, what we do, we compress. Yes or no?
So reduce the disk space.
Yeah, yeah. Similarly, because in the data warehousing we are dealing with large volumes of data, and even tables itself is too large. So tables are automatically compressed here in Redshift also. Okay, I mean, in other databases we use the term called compression, but in the Redshift we use the term called encoding. Encoding in Redshift we use the term called encode. Okay, but in other databases the term called compression. For example, in Teradata also we use compress. Okay, but here we don't use the term technically or officially compress, but we use the term called encode. Okay, encode. For example, you see. Okay, so I think I have already showed like this. Yeah. See, for example, I create a table like this, let's say. If I give show table, then it will show, department number integer AZ64. Then department, I mean, if I want to view the detail, it will show like this. But I created table like this only. Okay, department number integer, department name varchar, location varchar 20. Like this I created. But if I give show table, it will show the data like this. Department number integer, AZ64, and this is LZO, and location LZO. If there is any columns are there, it will just show AZ64 or LZO. Okay, generally for integer columns, it will give AZ64, and for varchar or character columns, it will just 6 LZO. So because these are the latest compression that will give the best compression storage. Okay, and similarly, AWS was there since more than some 8-10 years. So at that time, some compression techniques are there, but now these are the latest. So if you create table with some, let's say you create with AZ64 and LZO, tomorrow some new technique may come. So at that time you're not taking the benefit of that. So AWS recommends don't give any of these things. Just create with your columns. We will take care of your compression internally. So that's why we create DDLs without mentioning any encoding. We call encoding instead of compression, but yeah, it is the Redshift term, but it is concept called compression only. So tomorrow, if new compression techniques comes which is better than AZ64 and LZO, then that will be shown here. Some new came, let's say, new encoding. That means if with current encoding, let's say with current encoding of AZ64, and LZO. Okay, LZO. Let's say it saved. Okay, this 1 TB table. 1 TB table it saved to 60. No, 1 TB, right? So 1 TB table 2 it saved to 600 GB. 1 TB means 1000 GB. Okay, so with this current it saved its space from 1 TB to 600 GB. Then with new concept it saved to, let's say, 500 GB. Then yeah, so it will use new compression only, whatever the new encoding. So encoding, no, what is encoding? If that is the question, yeah, take everything as a question in my class. What is encoding? Okay, that is the way we ask in the interview. What is encoding? Redshift automatically applies compression. You can answer in your answer. You can say compression, so that he will know that you know already what it is. Encoding means compression. Okay, Redshift automatically applies compression or encoding at the time of creating a table. Okay, so encoding is to reduce the size of a table on the disk bus. You understand?
Yes.
Yeah, this is covered, right? But we forgot. Yeah, don't
Yes. Yes.
worry. I know.
While
Okay, I know
mentioning
that.
the table size, you mentioned.
Yeah. So yeah, you see compression encodings. Okay, if you open the AWS dot, okay, docs dot, then here you will see like what are different types of encoding. Try to have a habit of googling only docs.aws.amazon.com, because things will change over time, especially AWS things will change very fast. Okay, fast means there is always some new inventions are there on every service. So if any new things will be updated here. So you see AZ64 is basically for any integer type data types. Okay, small int, big int, integer, decimal, everything. Okay, so LZO. Okay, although yeah, it can be used for small int and all, it is basically used for character and varchar. Okay, so yeah, once we starting creating tables, then you will observe the same. Okay, we can create a table and see show table, then it will show the detail of the table. Then we can see for character what encoding it applied. It applies LZO for characters. Okay, so yeah. And then before here, these are all older. Okay, but don't refer them. You see, ZSTD was there. It was used for everything. See, it was used for everything. Integers, char, varchar, timestamp, for everything. ZSTD was used. Okay. Then you see LZO is there. Then char, varchar, timestamp. But later on, you see, AZ64 came only for here. There is no char, varchar. Okay, that is specially for integers and timestamp, like that. Okay, so if tomorrow if something else comes which is more advanced, that will be shown here. Okay, if yeah, so that will be used by the Redshift automatically. That is the reason we are not supposed to mention it as a best practice. Just leave it. Redshift will automatically take the best compression technique or compression encoding. So basically here, what is encoding? Redshift will automatically apply encoding at the time of creating a table. Okay, so encoding is to reduce the size of a table on the disk. Okay, Redshift will automatically take care of it. But that's what he is expecting, and that's what you should say. And different encodings. Yes, I know. What is that? You can say these names. Some AZ64, LZO, and all. Okay, yeah, raw. What is raw? Raw means no compression. Only if you create a column sort key. Okay, sort key columns will not be applied in encoding. Means if you for example, you have created, okay, you have created department number as the sort key, then there will not be any encoding applied on the department number. So it will be shown as raw. I will show this while creating tables. No worries. Everything we will see. Okay, so if a table does not have encoding, means it will show as raw. Raw means no encoding. Okay, so Yeah, so this is what is the purpose of encoding? Encoding means compression. Okay, it is to reduce the size of a table on the disk bus. Okay, no worries. Okay, so these are all terminology you need to get familiar with. Tell me what is skew?
Uneven
Tell me
distribution
what
of
is
data
skew?
across the slices. Uneven distribution of data across the slices.
Yeah, is called skew. That's all. That's all. Okay. So what is the acceptable level of skew? What is the acceptable percentage of the skew? What is the value that is accepted for skew? What is the value that can be accepted for skew?
Semi.
What is the acceptable value of skew, or what is the ideal value of skew?
80%, sir.
Hmm?
20% skew we can tolerate.
Okay. Yeah. Okay. Yeah. Yeah. I think skew can be okay, acceptable up to 15-20%, or even up to 30% is also okay. Okay. Skew means what? Uneven distribution of data. Okay, across all the slices. So if one table has 100 records, other table has 130 records, or other table has 80 records, that's fine. Okay, so but one table has 100 records, another table has 200 records, not like that. Means some slices are empty, some tables are full of data. No. Okay, so skew means uneven distribution of data across slices is called skew. Okay, up to 20-30% of skew is okay, acceptable. Okay, okay,
Yes.
yeah,
Yes, sir.
20-30% skew is okay, accepted. Okay, so that's not impacting your performance. But yeah, ideally skew should be 0. Okay, or ideally, but that will never happen, so no worries. Okay, so up to 20-30% is accepted skew. That should not be a problem. You can say like that. Even he don't say that it should be. Okay, in real time that will not happen. Okay, so better that skew is, or we avoid this skew, means better that we don't unevenly distribute the data. How to avoid skew? How we avoid skew? Can you tell me? How can we avoid skew? Prasad, can you tell me how to avoid skew?
Using distribution key, sir.
Yeah. Yeah. How? How? You see, if you tell like that, he will not get convinced. You should convince him.
Using
Somnath, can you tell
the
me?
distribution key style, list key.
Yeah, yeah. You should say that we should select the list key in such a way that it will evenly distribute the data. You should tell 100% correct answer, man, not some this one small. Means you yourself is
Okay.
doubting whether it's right or wrong.
Okay, sir.
Okay. Why skew is coming? It is coming because data is unevenly distributed. That is what we know, it is skew. Okay, how to address that? Then you distribute the data evenly. Then how do you distribute the data evenly? Choose the disk in such a way that the column which can even distribute the data. Bas. Simple. Use your analytical common sense only. Why skew is coming? Because data is unevenly distributed. Why it's unevenly distributing? Maybe the distribution key is not correct. Then choose the distribution key in such a way that which can evenly distribute the data. Bas. Change the distribution key to column which can evenly distribute the data. That will avoid this skew. Do I make sense?
Yes.
Yes, sir.
Yeah, use your common sense and ask. No need to get afraid or no need to get panic. Okay, these are all common sense questions. Okay, but you need to know what is skew. Then you think how it came. Then you know how it correct. If you see, for example, you went somewhere. If you know how you went there, then you can easily come back. If you don't know how you went there, how you can come back? Same thing. So if you know why the issue caused, then you can address that. Okay.
Yes.
Yes, sir.
Okay then. Cool. Thank you and have a great day. We meet you tomorrow. Huh?
Yes, sir. Tomorrow.
Yes, yes, sir.
Okay. Sure. Huh? Take care.
Thank you, sir.
Thank you, sir.
Yeah, yeah. Bye. Bye.